Hi everyone. So today we're going to be talking more about factoring, and we're going to be talking about factoring trinomials with a leading coefficient of 1. But before we go into that, I want to talk a little bit more about factoring because I realize that I've been doing these videos about factoring, but I really haven't explained why we're doing factoring or what it is. So the best way I can explain it is that factoring is like reverse multiplying. Reverse multiplying. So in the last unit, you learned how to FOIL, first outside, inside last, with two binomials. And we would FOIL and we'd get something that looked like this. We'd probably get a trinomial or another binomial. But factoring is taking that and going the opposite way. So we're taking this and we're trying to find what it originally looked like, or what it looks like in its factored form. I think that's pretty cool. So when we factor, what are we really doing? Like, where do these numbers come from? And how do we find these specific numbers given this trinomial? Well, if we take a deeper look, in this example, we have x plus 3 times x plus 4. And this, when we FOIL, gives us x squared plus 7x plus 12. But where do those 7 and 12 come from, and how can I use them to tell me what those numbers are in the first place? Well, that 7 looks a lot like a combination of 3 and 4. But that 12 also looks like a combination of 3 and 4. So let's think about that for a minute. I'm going to give you a minute to think about how we could get 7 and 12 from 3 and 4. Okay, did you try it? So 7 I can get by adding 3 and 4. 3 plus 4. And 12 I can get by multiplying 3 times 4. This is going to come in handy when we're factoring trinomials with a leading coefficient of 1. And that whole thing about a leading coefficient of 1, that just means that the coefficient right here in front of my x squared is a 1. Technically, we don't even see it because I don't write 1x squared, but that's what I mean. So this whole thing about adding and multiplying, when we factor something like x squared plus bx plus c, we will get a factored form like x plus a number times x plus a number, where those numbers in there will add to b. So we'll add to that b term right there, and they'll multiply to c. So those two numbers right here are going to add to b and multiply to c. So let's see it in action. Let's do a few examples. Okay, our first example is x squared plus 6x plus 8. And I want to get this from this trinomial with a leading coefficient of 1 to a form that looks kind of like this, where I have two factors multiplied together. So I first need to find these numbers that are going to go in here with my x's. So what am I going to do? I'm going to find some numbers that add to 6. Remember that term in the middle? I need two numbers that add to 6 that also multiply to 8. So I have some options here. What adds to 6? Well, let's think of some examples. We have 1 and 5. We have, 2 and 4. And we have 6 and 0. 3 and 3. How about multiply to 8? What do we know that multiplies to 8? Well, we have 1 and 8. We have 2 times 4. That's multiplied to 8. And that's about it. That's easy to multiply. So let's see if there's an overlap here. Well, both of these have 2 and 4. So let's try it and check it and make sure that it works. So we're going to have x plus 2, one of those numbers, and x plus 4. It really doesn't matter where you put both of these numbers. You can flip those around, x plus 4 times x plus 2, because when we're going to FOIL, we'll get the same thing. So let's check it by FOILing. So we're going to do first, outside, inside, last. So my first terms are x times x. That's x squared. Outside is x times 4, so I'm going to do plus 4x. Inside terms, 2x. And last are going to be 8. So 2 times 4. 4x plus 2x, that's going to be 6x. So I'll get x squared plus 6x plus 8. And this should be what I started with, and it is, so that's awesome. This is super important. You can always check yourself when you do these, and I would really recommend it. All right, moving on. Example number 2, I guess. X squared minus 10x plus 16. So we're going to have to find some numbers here that add to something and multiply to something else. What should those two things be? Well, they're going to add to negative 10. I have a negative 10 in there instead of a positive. And they're going to multiply to my last term in there, which is 16. So let's think of some numbers that add to negative 10. Well, we have a few options here. We could have negative 5 and negative 5. We could have 10 and negative 20. We really have a lot of options. So I might start with the one that says multiply to 16. Let's try that. So I could have 4 and 4, or negative 4 and negative 4. I could have 8 and 2, or negative 8 and negative 2. I could have 16 and 1, or negative 16 and negative 1. But let's check and see if any of these work. So 4 and 4 don't add to negative 10, or negative 4 plus negative 4. But negative 8 plus negative 2 equals negative 10. So if I put negatives in front of here, I think I'm going to get something that works. So negative 8 and negative 2, those add to negative 10. So my factored form here, I'll write it underneath, I'm going to say is x minus 8 times x minus 2. That's x plus negative 8 times x plus negative 2. But I just made them subtraction. All right, I'll leave you to check this one to make sure that it's correct, but we should always do that. I'm going to move on to the next example. Okay, in this example we have x squared plus 7x minus 18. So I'm going to have to find factors that add to 7, positive 7, and multiply to negative 18. It's important to pay attention to those signs. So I have some options here, but I know that one of my numbers is going to be positive and one is going to be negative, because when I multiply them, I'm going to get a negative. And remember, a positive times a positive is a positive, and a negative times a negative is a positive. So I have to have a positive number and a negative number. So let's think about this. What multiplies to negative 18? Well, I could have negative 2 and positive 9, or the other way around, 2 and negative 9. Or I could have, let's see, negative 1 and 18, or negative 3 and 6, or the other way around. These can all be flipped. So let's think about these. Do any of these add to 7? Well, actually, our first choice adds to 7. Negative 2 plus 9 is 7. So that works. So we can write that in there. Negative 2 and 9. We have a pair. And now I can use those as my factors. So my factored form, this is going to equal x minus 2 times x plus 9. And again, this is really x plus negative 2, but I made it x minus 2. Same thing. All right, let's move on to a word problem. All right, so what do we have here? We know that the area of a rectangle in square feet can be represented by x squared plus 8x plus 12. The length is x plus 6 feet. What is the width? Well, let's take a step back. What do we know about rectangles? What do we know about the area of rectangles, to be specific? I drew a rectangle for myself just because I like to visualize things. I recommend it. Makes word problems a lot easier. So if I visualize a rectangle and I'm trying to figure out the length and the width and the area, I can remember that area equals length times width. And my length is this, and my width is this dimension. So I can fill in a few things that I know. My area, they tell me, is represented by x squared plus 8x plus 12. So that's x squared plus 8x plus 12 is my area. So I can plug that into my equation. And they also tell me the length is x plus 6. So I have x plus 6 over here, and then they ask me, what is the width? So I have the length, so I can kind of fill in this here. This is going to be x plus 6, but I'm trying to figure out what this dimension is. And I can use the fact that this is a trinomial with a leading coefficient of 1, and I know that I'm going to have a factored form in the end, so this is going to have to be x plus 6 times something over here. And how can I figure this out? Well, I already have one of my numbers that I'm going to be using to factor. So I need numbers that add to 8 and multiply to 12, right there. And I already know one of them is 6. So, well, what do we add to 6 to get 8? And what do we multiply 6 by to get 12? Those answers should be the same. 6 times 2 is 12, and 6 plus 2 is 8. So my other factor here is going to be x plus 2. So that means my width here is x plus 2. And you can check yourself. You can always FOIL and make sure that you get that same answer back. All right, with that, I will leave you to try the problems at the bottom of your guided notes.